Hello, curious people. Today I will be explaining. Oh, wait, excuse the bad setup, by the way. But today I will be explaining ionic bonds. Ionic bonds. It was gonna be different bonds, like all of them at first, and there's only like two. Or two main types at least. Well, three. Well, four. Oh, okay. I was gonna explain all of them, but then I realized this took up a lot of space, and I don't feel like writing all that, so it's just going to be restricted to ionic bonding. And so yeah, let's start with number one. So remember this guy? This is technically this is chlorine, but I just kind of randomly made it up. Anyways, what's important here are the electrons on the last shell. Remember, this is what we call the valence shell. Remember that? Yeah. The valence shell is the most reactive shell because it contains the most energy, and the inner shells are less reactive because they don't have as much energy as the valence shell. So, this makes valence electrons really, really important. This is like the basis of all bonding, I think. And so, wait, let's go over one thing first before I start talking about bonding. So, you have these things called groups and periods on the periodic table. The groups are the columns, so 1, 2, 3, 4, 5, etc. Those are groups. Those show you how many valence electrons are in each element. You know, skipping on the metals in between. And the orbitals, or aka the periods, are the rows. So horizontally, here, hydrogen and helium would have one orbital, and so on and so on. And that's how we determine how many valence electrons or how many energy shells there are in a certain element. You know, again, excluding the metals. Also, helium has 2 valence electrons and not 8, like the rest of the noble gases, but it still has a full valence shell, which still makes it a noble gas. So, just thought I should include that. Anyways, back to over here. So, like I said, valence electrons, really important, right? So, how are they important? Well, let's go to two random non-selected, like non-pre-selected molecules. They're elements, my bad, not molecules. Not yet, at least. Anyways, you have sodium, or Na, and then you have chlorine, or Cl. Sodium has 1 valence electron, and Cl has 7 valence electrons. You can see by the little dots. Okay, so you might be wondering, so what? Who cares? Well, look at this. Sodium, this is the Bohr model for sodium, and basically, in the first shell, it has 2 valence electrons. Not 2 valence, sorry. 2 electrons. In the second one, it has 8. And then the last one, it has 1. Weird, right? I know, it is really weird. And then chlorine, in the first one it has 2, in the second one it has 8, and then in the last one it has 7. Not quite 8. So, you might be wondering, again, so what? Who cares? Well, remember the octet rule? Oops, so sorry. Remember the octet rule? The whole having 8 electrons in a shell thing makes elements happy? Well, yeah. So, this is going to be important, and just like give me about 20 seconds. So you have Na with the 1 valence electron, and you have Cl with another valence electron. And so Na and Cl have a bright idea, saying, hey, I have 1, you have 7, how about I give you 1, and you just keep that 1, so we can both have full octets. And then sodium gives chlorine its valence electron, and so now sodium only has 2 shells now, 2 energy shells. But in the second energy shell, it has 8 valence electrons, which means it fulfills the octet rule, and chlorine now has 8 valence electrons because it took an electron from sodium. So, let's go to the back. Now sodium and chlorine have a full octet, which means they are both very, very happy. And when this happens, they form a bond, or fusion, if you've seen Dragon Ball. If you haven't, then this won't make much sense. And they form a thing called an ionic bond, which can allow them to do really cool stuff, like become table salt. Yeah, that's right. Sodium and chloride, or sodium chloride, or sodium and chlorine, when they ionically bond, which they always do because of the unequal amount of valence electrons, they form table salt. So yeah, and table salt is yummy. So anyways, chlorine is called an anion, or chloride is called an anion because it took the electron from sodium. Sodium is the cation because it gave away the electron. And you can see I did the cation is an angel and the anion is a demon because the anion stole or whatever. And yeah, so because sodium gave away one electron, it now has more protons in the nucleus than it does electrons on the outside, and therefore it's a positively charged ion. And because chlorine took the electron, it now has more electrons than it does protons in the nucleus, which means it's a negatively charged ion. And I wrote that up there. And that's the last thing I wrote. So yeah, that pretty much explains ionic bonding. I really wanted to talk about covalent bonding, and then nonpolar and polar covalent bonding, and then hydrogen bonds. But I'm lazy, so I didn't do all that. Hopefully this made sense. If it didn't, go watch the Amoeba Sisters and go watch Crash Course because they are better explainers than I am. But yeah, this is just me explaining it to the best of my ability because I find it interesting. So anyways, yeah, that's about it. Hope you have a great day. Bye.